Okay, so I figured it might be a good idea to throw in another example of coffee cup calorimetry for you all. And in this case, we are identifying an unknown metal, or at least the specific heat of an unknown metal, based on the change in temperature of water that it has been added to. Okay, so in this problem, we've got a 17.3 gram piece of unknown metal. The metal has been heated to 100 degrees Celsius and then added to 46 milliliters of water, and the water started out at 25 degrees Celsius. When it is added, we see that the temperature of the water rises to 39 degrees Celsius, and from this information we can find the specific heat of the metal. Okay, so here's our picture for you all. Taking a look, we can see where the temperature starts and ends. Take note, we went up to 39 degrees from the water, and also the metal is dropping down to 39. So that's another really important idea when doing these problems. Wherever the water rises to, that's where the metal falls to in terms of temperature. So this is our final temperature of both the water and the metal after all the heat has been exchanged. Okay, so another concept to keep in mind is that whatever heat was gained by the water was also lost by the metal, okay, because the metal is losing its heat energy to the water. So they're going to be completely equal in terms of that heat, okay? So the first thing we're going to do is calculate the heat gained by the water using Q equals MCAT. Here we're using just the weight of the water. So we had 46 milliliters of water, so that converts to 46 grams because it's 1 gram per milliliter unless otherwise stated. This is different than the previous problems that we've done where we dissolve something in the water and then we add the weight of the thing dissolved plus the weight of the water. The metal is not dissolving and adding to the solution. It's staying separate from the water. And so if the metal stays separate from the water, we don't add it to the mass of the water. Okay, so if things are dissolving, add it to the mass. If things stay separate, do not add it to the mass. Okay, that's the rule of thumb. So anyway, heat gained by the water, mass of the water, specific heat of the water, how much the water changed in temperature, again 25 up to 39. This gives us how much heat was absorbed by the water. Okay, where did this heat come from again? It came from the metal, so now we can make that our Q from the metal because now we know how much heat was lost by the metal. That's equal to the mass of the metal times its specific heat and its change in temperature. And again, it started out at 100 degrees and dropped down to 39. So now we know the metal lost this much heat, it started out at this mass, and it lost this much in terms of temperature. And plugging all that out, we can figure out basically by solving for x what the specific heat of the metal is. Okay, this is exactly the calculations you guys are going to have to do when you are doing your lab coming up this week. So I hope this makes sense, and again, if this doesn't make any sense to you, come talk to me.